Welcome to the Deep Dive. If you work anywhere near heavy industry, I'm talking refineries, chemical plants, power generation, the line between a normal day and a total catastrophe can be just one signal.
One signal that either works or doesn't.
Exactly. And everything depends on it. We're talking about environments where downtime isn't just an inconvenience, it's millions of dollars. And where safety failures, well, they're just not an option.
Not at all.
So today, we're doing a deep dive into the source material on a piece of critical hardware that's built for that pressure. It's the Det-Tronics EQ3730 Enhanced Discrete Input-Output Module, or EDIO for short.
This is the gear that literally stands in the gap.
Right. And our mission here is to get past the marketing language and really unpack why this specific I/O module is being framed as the key to, the source calls it mission-critical integrity.
And we have to start with what that I/O module even is. In simple terms, it's a translator.
Translator.
Yeah. It takes what's happening out in the field. A flame detector sees a fire, a gas sensor screams danger, and it translates that into a simple, certain command for the control system.
A discrete command.
Yes, discrete. That's the key. Not analog, it's not a measurement, it's a binary fact. It's on or off. It's danger or safe. There's no in-between.
And the problem the source points to is that generic hardware, it can't handle that. It gets fuzzy.
It gets fuzzy, and that ambiguity, that hesitation, that's what leads to shutdowns that are, they're costly, they're dangerous, and honestly, they're often completely avoidable.
Okay, so let's unpack the tech that supposedly avoids all that. What separates this EQ3730 from what the source calls the gear that begs for mercy in a tough spot?
Well, it starts with flexibility, but a really robust flexibility.
Let's start with configurability. The module has 8 channels.
8 channels, and each one can be what you need it to be. An input, an output, you decide.
So you could have one channel monitoring a gas detector, and the channel right next to it could be controlling a fire suppression system.
Exactly. They're completely independent. But the real cleverness is in the wiring. The source makes a big deal about its ability to handle things like Class A wiring.
Let's pause there. Class A wiring. For those of us who aren't deep in electrical standards, what does that actually get you?
It gets you reliability. Real reliability. Think of it this way. In a standard Class B circuit, if a single wire breaks, that's it. The whole safety loop is down.
The signal's lost.
It's gone. But Class A is a loop. It's a circle. So if the wire gets severed somewhere, the signal just turns around and goes the other way to get back to the module.
So you're buying a backup path,
Yeah.
an automatic safety net.
That's a perfect way to put it. It's a safety net built right into the wiring. For a critical facility, that kind of fault tolerance it's just massive.
And what about the communication itself? The source talks about ultra-reliable communication. That sounds great, but what does it mean mechanically?
It means it's built to ignore the noise.
What?
Electrical noise. An industrial plant is an incredibly noisy place, electrically speaking. You have huge motors kicking on, welding happening. All of that creates interference.
And that interference can scramble the signal from a detector.
It can make a safe signal look like a danger signal, or worse, it can delay a real one. The Det-Tronics protocol is basically designed to hear the true signal through all that chatter. It ensures the message gets through instantly and cleanly.
And we're not even talking about the physical toughness yet. This isn't sitting in a nice air-conditioned server room.
No, absolutely not. This is bolted to the side of a processing unit. It's getting baked by the sun, rattled by vibration, exposed to chemicals. It has to survive for decades in an environment that would kill office tech in an hour.
So that physical build, the seals, the housing, that's the foundation for everything else we've talked about.
It is. If the box fails, the brilliant tech inside doesn't matter.
Right. So let's shift from the tech to the bottom line. Let's talk about operational efficiency and the total cost of ownership, the TCO.
And this is where the conversation gets really interesting for anyone managing a budget, because the cheapest thing to buy is almost never the cheapest thing to own.
Especially in this industry.
Especially here. Uncertainty is the most expensive thing you can have in a plant.
So the source talks about ditching the cabling nightmare. How does one small box actually save that much on wiring and installation?
Well, think about it. Every single cable you have to run is a cost. It's the cable itself, it's the labor to install it, the labor to test it, and it's another potential point of failure for the next 20 years.
So by having 8 flexible channels in one spot, you're just running fewer wires.
Drastically fewer.
Yeah.
You reduce the complexity, the footprint, the labor, and you reduce the chances of something going wrong during installation or maintenance down the road. It's about doing less and getting more accuracy.
And that leads right into the cost of false alarms.
Oh, that's a huge one. When a cheap I/O module misreads a signal, maybe a power surge looks like a gas leak, what happens?
You get an evacuation, production stops.
Production stops. You have people investigating a ghost. The cost of a single shutdown and restart can easily hit six figures, sometimes more.
And the EQ3730, by providing that clean, certain, timestamp data, it just eliminates that chaos.
It eliminates the "what was that signal" question. When an alarm goes off, you know it's real. You act with certainty, not with doubt. And think about the regulatory side.
Right, the paperwork.
Every false alarm has to be documented. And if you have a pattern of them, your insurance provider starts asking questions. Having clean data builds a trustworthy operational history. It proves your system is stable.
Now, there's one feature here that seems like a total game changer for the operations teams. The hot swappable modules.
Oh, this is a huge strategic advantage.
Explain that. Why is it so important?
Because normally if you have to replace a critical I/O card, you have to power down that entire section of the safety system.
Which means you have to shut down the process.
Right. So you wait for a planned, facility-wide shutdown, and you cram all your critical maintenance into that tiny window. It's stressful, it's risky.
But hot swappable means?
It means you can walk up to the panel while the system is live, pull the module that needs work, and slide a new one right in.
Without any downtime.
Zero downtime, zero process interruption. The rest of the safety system doesn't even blink. It turns reactive, emergency maintenance into proactive, scheduled work you can do on a Tuesday morning.
That feels like it buys you operational continuity. It's the definition of stability.
It is.
Okay, so let's put on a different hat. Let's think like a safety manager. Their mantra is zero compromise, zero confusion, maximum response speed.
And for them, the customization is everything. Those 8 configurable zones let them map the hardware directly to their facility's specific risk profile.
You're not trying to fit a square peg into a round hole.
Exactly. You're not compromising your safety design to fit the hardware's limitations. You're making the hardware fit your design. A smoke detector here, a heat detector there, a manual pull station. You mix and match channel by channel based on the actual risks in that specific area.
And for compliance, for the auditors.
It's a dream. Audits are a nightmare when your event logs are a mess of ambiguous signals and unexplained failures. But with this, the logs are clean. They're certain. They're time-stamped.
It's irrefutable proof.
It's irrefutable. You can show an auditor, here is every event logged perfectly. It demonstrates you're ahead of the regulatory risk, not just meeting the bare minimum.
What about future-proofing? Codes change, technology gets better, you don't want to buy a system that's a dead end in 5 years?
That's a critical point. A safety system isn't like a laptop. You expect it to last for decades. Det-Tronics, according to the source, is committed to that long-term innovation, so the module you buy today will still integrate with the next generation of sensors tomorrow.
So it works for a brand new project, but also for upgrading a plant that's been around for 40 years.
That backward and forward compatibility is a massive advantage for anyone doing long-term planning.
All right, so we've got the tech, the TCO, the compliance. But this all sounds great in theory. The source material had a real-world example, right?
It did, a really powerful one, a big petrochemical facility. Their existing I/O solution was, well, it was unreliable.
Causing false alarms.
Worse, it caused 2 separate full-scale evacuations based on signals that were completely ambiguous. Think about the cost of that. The lost production, sure, but also the damage to morale.
When the crew stops trusting the alarms.
That's a safety nightmare. If people start thinking, oh, it's probably just another glitch, you are in a very dangerous place.
So what happened when they switched to the EQ3730 modules?
The change was immediate. The source says the event logs became crystal clear, the false alarms stopped, and the best part, their next safety audit was labeled flawless.
That one word says it all.
It really does. It's the difference between guessing and knowing.
Okay, this brings us to one last really crucial piece of the puzzle. The supply chain. You can have the best hardware in the world, but if you can't get your hands on it, it doesn't help.
And in safety, supply chain risk is safety risk. If a module fails and the replacement is 6 months out on a container ship somewhere, what do you do?
You're either running with degraded safety or you're shut down. Neither is a good option.
Not at all. And that's where the source highlights the value of a specialized supplier like PE Energy. They position themselves as more than just a reseller.
They call themselves solution architects.
Wow.
What does that actually mean for the person trying to get a project done?
It means they don't just sell you a box. They provide guidance on how to configure it for your specific needs, for your specific hazards. They can help bundle it into a custom panel, help with the integration.
They'll help you avoid the mistakes?
Exactly. They speed up the whole process from design to commissioning. But maybe most importantly, they promise to have inventory in stock.
Which is huge.
Oh.
Knowing you can actually get the part you need when you need it,
Yeah.
that removes a massive headache.
It takes the supply chain risk off your plate so you can focus on running your facility safely. They're selling certainty in the hardware and certainty in its availability.
So let's bring this all together. We've gone through the tech, the operational wins, the safety case, everything around this EQ3730. And what it really boils down to, it seems, isn't just hardware. It's about buying certainty. It's about buying uptime. It's about buying the trust of your entire crew.
It's about moving from being reactive, always chasing ghosts and putting out fires, to being proactive, to having a rock-solid safety system where every piece of data is treated as gospel because it is.
The source material ends with a really powerful line. Your facility is only as safe and productive as its weakest link.
And that's the whole lesson right there. We spend so much time and money engineering these huge, complex systems.
But we overlook the small parts.
We overlook the small, crucial components, the translators, the little I/O modules that have to turn danger into action. And if that link is weak because it was bought based on the lowest price, you've built a vulnerability right into the heart of your system.
And the true cost of that weak link is always, always higher than whatever you saved on the sticker price.
Orders of magnitude higher.
So, as you think about your own facilities, your own critical systems, our final thought is this. Where are your essential translators? Are they giving you guaranteed certainty? Or are they an uncertain weak link you just haven't paid the price for yet? Something to think about until our next deep dive.